Are you
Oh,
ready to do a physics problem?
I was born ready.
I thought so. I looked at that face and I thought, this guy can't wait to do some physics today. Okay, can you read number 53?
A falling stone takes 0.31 seconds to travel past a window 2.2 meters tall. From what height above the top of the window did the stone fall?
Okay, what are we looking for here?
We're looking for the distance or the total distance the stone fell from.
Right, the distance it falls before reaching the top of the window. So, delta x is unknown, and it's what we're solving for. Some people would call this delta y because it's a vertical distance. What do we know before it reaches the window?
We know how tall the window is and how long it took for the stone to fall to the bottom of the window, I believe, from where it was dropped, which might be even higher than the window is. And that took 0.31 seconds.
Right. So that's actually a second portion of things. We're going to call that delta x of the window is going to be negative 2.2 meters because it's falling 2.2 meters. We're going to say that the time is equal to 0.31 seconds. And I'm actually splitting this into two categories. So the first category is above the window. This is before it reaches the window. And keep in mind, we need to include this because we're trying to solve for the distance it falls before reaching the window. Whenever they first let go of it, the velocity initial is going to be equal to 0 because at vertical velocity, it just started to fall. The final velocity, we're going to consider this to be whenever it reaches the top of the window, and it's unknown. Similarly, that can be the initial velocity whenever it's passing the window. It's unknown. So these two are equal. The final velocity above the window, whenever it reaches the top of the window, is equal to the initial velocity as it's passing the window. Does that make sense?
Yes, I believe you told me when something's falling, it doesn't just keep increasing speed. It hits a certain speed and sticks with that consistent speed until it hits the ground.
That is true, but that doesn't apply here. The reason
Okay.
is that applies whenever something's falling and there's air resistance. And usually in reality, that's always the case. There's always air resistance. But in physics problems, we don't have air resistance for some reason or another in the majority of these kinematics problems.
Oh, so just for the sake of the problem, it's telling us that it's going to hit that consistent speed once it gets to the top of the window. It's just convenient for solving the problem that way.
Yes, exactly. So
Okay.
here's our window. And before the window, you drop it and V initial is equal to 0. Now, as it falls above the window, we stop it at this height. And at this height, V final is unknown. Then we would start the second portion of things. The second portion, V final, is going to be considered V initial of the second portion. It's also unknown, but these two are equal because they happen at the same point at the top of the window. So above the window, V initials is 0. We actually don't even know the time that it's falling, right? We definitely don't know delta x, that's what we're solving for, the height it falls before reaching the window.
Yeah,
The
we
one
only know the time for passing the window itself, not above it.
exactly. But the constant we do know is that the acceleration is negative 9.8 meters per second squared because that's gravity and it's in free fall. We can actually put that for both of them. But first, let's put that v final as it's passing the window is also unknown. And then acceleration for both of them is negative 9.8 meters per second squared. So acceleration is a constant. It's falling. Gravity's always negative 9.8. Above the window, delta x is what we're solving for. It's the height it falls before reaching the top of the window. V initial is 0 because we drop it from rest. V final is unknown, and it is going to be equal to the V initial as it's passing the window. The height of the window, delta x, is 2.2 meters. We have that here. The time it takes to pass the window is 0.31 seconds. That's the amount of time it takes to fall past the window. And so I'm looking at this. Can we solve directly for delta x, the distance it falls from above the window, with the information that we have in this left side here?
I think if we can calculate with the force of gravity, we might be able to find it from that.
Maybe. Let's try and think about it. So we can't use the first kinematic equation, right? Because it doesn't include delta x.
No.
The second one's an option. What is missing here? We're missing delta x, of course. Are we missing anything else?
We're also missing time.
We're missing time. That's a big one. Yeah, so we have two unknowns. We have to think, is it possible to get the amount of time it falls in the first part using the second portion?
Oh, like using equation 2 for the passing window part of the problem?
Maybe. See, I don't think there's a correlation between the passing window problem and the time it takes to reach the window. I think it's possible to calculate it, but it seems kind of difficult, honestly. Let's really fast look at number 3. V final squared equals V initial squared plus 2a delta x. What unknowns do we have in this question?
We don't know the final velocity.
Right?
We don't know delta x.
Yes, those are the main two. For the above the window portion, we don't know final velocity and we don't know delta x. However, what can we solve for in the passing window portion that will give us the final velocity above the window?
Let's see. Well, we have delta x and we have the acceleration.
Remember, what is equal to the final velocity above the window in the passing window portion?
Is it equal to V initial?
Yeah, exactly. If we can calculate V initial for the passing window portion, then we already have V final for the above window portion. And then we can use that and plug it into equation 3. That's tricky. Let's go ahead and do it. Let's solve for V initial in the passing window portion, or let's try to. Which equation could we use to solve for V initial on this side of things?
Could we use number 3?
Number 3. Let's see. So V final squared. Do we have V final here?
No.
No. Do we have V initial?
No.
No, that's what we're solving for. So that's two unknowns. So there's a better equation here that we could use in which we're only solving for V initial.
Could we use number 2?
Let's try it. Delta x, we have that. V initial is what we're looking for. We have the time, we have the acceleration, and again, we have the time. So yeah, that one can work. I'm going to scroll down a little bit here, and we're going to be using this passing window portion to solve. So I'm going to set up our second equation. We have delta x equals V initial t plus 1/2 at squared. Do you want to do the algebra first, or do you want to plug in the numbers first?
I want to plug in the numbers first.
Let's do it. What is delta x? Negative 2.2. Negative 2.2 meters equals V naught is unknown. What is our time?
Our time is 0.31 seconds.
Nice. Plus 1/2. What is acceleration?
Negative 9.8 meters per second squared.
Perfect. And then again, our time is 0.31 squared. Okay, let's begin to solve this. Negative 2.2 equals 0.31 V naught. You can just rearrange those. Plus, can you do 1/2 times negative 9.8 times 0.31 squared on your calculator?
I guess I won't know until I do it.
I'm going to do the same. You're like,
oh, I thought that was like a rhetorical question. Like, is this even possible? And I'm like, oh, I don't.
I thought you were just saying, regretfully, I can.
Okay, I got a syntax error.
Oh, can you tell me what you typed in?
I did type in 0.5 for 1/2.
That's fine. Whenever you did, don't worry about the negative. You don't have to do that.
All right, so I have 4.9 because I withheld the negative, but it should be negative 0.9. I just have to remember that.
That's fine. Yeah, we can put that at the end.
Okay.
And then times 0.31 squared.
My answer was negative 0.47.
Perfect. And we know it's negative, so we make it minus that. Now, what we're going to do is we're going to add this to both sides. So add the 0.47 to both sides, and we have to do negative 2.2 plus 0.47.
So I got 2.67 on the left side.
Close. Remember, it's negative 2.2.
Oh,
So this time we do have to be careful with that. And you can do it two ways. You can either do 0.47 minus 2.2, or if you know where the negative button is on your calculator, you can do negative 2.2 plus 0.47. The reason
then
you
I
got a
got
syntax error before is because you put the minus sign.
I got negative 1.26 instead now.
Not what I got. I got negative 1.73. Could you tell me what you typed in?
Negative 2.2 plus 0.47.
So you have to be careful that you don't put the minus sign. The minus sign is going to take from the previous answer. Calculator stuff is tricky.
So I got 2.67 again without putting the minus signs in.
So at the very beginning, could I see your calculator really fast?
Yeah.
Got it. And bring it up a little bit on the screen so I can see the bottom of the calculator. There you go. Do you see next to, at the very bottom, it's one of the white buttons. There's a minus inside of parentheses.
Oh, am I supposed to be using that for the negatives?
That's what you use for negative numbers. If you
Okay.
use the minus sign, it's a different concept, but that means negative 2.2.
Now I got negative 1.73.
There you go. Do you understand the difference between the negative sign and the minus sign?
Yeah, I do know.
Okay, perfect. Yeah, this stuff's kind of tricky. Let's keep going. That's important. Calculator stuff is not easy. Finally, we had to divide both sides by 0.31. So we get V naught equals negative 1.73 divided by 0.31. Go ahead and do that on a calculator. And you can use the negative sign now.
This one I got negative 5.58.
Perfect. Meters per second, right?
Yeah.
So I'm going to go back up to the top. We have negative 5.58. I'm going to put that in for V naught. And we can put it in for V final for the above window portion because they're equal. Now we're ready to solve for delta x above the window. Let's do it. I'm going to take this portion here and put it off to the side. But let's squeeze that over here. I should probably be doing a lot more of this in general. And let's get this last little portion too. Okay. Now, what should we be using now that we have V final to solve for delta x in the above window portion of things?
Could we use negative 5.58?
Yeah, we can use that. Which equation should we plug it into to help us solve for delta x?
Actually, would number one work?
Close. What is number one missing?
It's missing. Oh, it's missing delta x.
Right, so we can't solve for it if we're missing it there. So number one is out for that reason.
Is it 2 again?
I'm going to have you analyze number two for me and tell me if we can use number two. So for example, say delta x, that's what we're solving for. V naught. Do we have V naught?
We do.
Nice. T.
Oh, I guess V final isn't part of the problem.
That's not a big deal as long as we have everything else.
Okay.
Do we have T?
We don't have T.
We don't have T. That's why we can't do it.
So I guess it has to be 3.
Yeah, but I want you to analyze number three. So you have to say V final. Do we have that?
We do have that.
Okay, keep going.
And then we have our V initial. We have A as well, the force of gravity. Then we don't have delta x, but we do have everything else.
Right, and delta x is what we're solving for.
Yeah.
Perfect. Nice. That's the exact process that we have to use whenever we're solving these. We just say we're only missing the one that we want. Okay, so V final squared. Actually, let's just go ahead and plug these in. For this one, I'm going to take a different approach. We're going to do the algebra first. V final squared equals V initial squared plus 2a delta x. We want delta x. And so I'm going to do the algebra to get it alone, and then we're going to plug in our numbers. What do you think is the first thing I should do to get delta x alone?
Is it possible to divide by delta x?
It could be, but that's not getting delta x alone. We want to get rid of everything else on the same side as delta x.
So is it better to subtract or divide those and put them on the side of v final?
Exactly. And whenever we're doing algebra, we want to work in reverse order of operations. So normally you would do multiplication and division first, but with algebra, we're going to do subtraction and addition first.
So could you subtract v initial from one side or each side?
Yes, we're subtracting v naught squared from both sides. So v final squared minus v naught squared equals 2a delta x. What's the next step?
Can we divide by 2a?
Yeah, perfect. And that's it. We literally get delta x, I'm just flipping sides here, equals v final squared minus v initial squared over 2a. Could put a circle around that. We just solved for delta x without any numbers necessary. But now we're going to plug in numbers.
Okay, so we know that v final is, it's still negative 5.58.
Exactly. We're just using all the information in this left column. So it's negative 5.58. We put that inside of parentheses and we square it, which is essentially going to make the negative not matter because a negative squared is a positive. What is v initial?
V initial is 0.
Perfect. And then what is a?
Negative 9.8.
Awesome. Can we solve this on our calculator?
I believe so.
I'm typing in open parentheses negative 5.58 squared divided by open parentheses. Oh, wait, sorry. It's open parentheses negative 5.58 close parentheses squared divided by open parentheses 2 times 9.8 close parentheses.
I got 1.59.
That's what I got.
And if you
And it should be negative 1.59. I should have put negative 9.8 in the denominator there.
and this is I forget the units of distance. Was it meters?
Yes, perfect. Awesome. Another tough problem, right?
Yes, another two-stepper.
Yeah, this one's a lot going on. But yeah, great stuff, Matt.